Hi, and welcome to this iOS video. In this video, we're going to talk about a little bit about automatic reference counting, what reference counting really kind of is, and we're going to start talking about it now and continue our discussion really of reference counting and memory management throughout the course. But I wanted to expose you to a couple ideas and also talk about what happens when we want to make a property out of an object. So far, we've used C primitive types, char and int, to make our properties. Today we're going to rework the part class to use an NS string instead of a char star for the name. And this is really what we want to do. In Objective-C, we want to use these next step or NS objects rather than char stars and things like that. So now, one thing, since we've only been dealing with C primitives, we've used the assign keyword in the property declaration. Now, assign just it says when you have a setter, when synthesize makes the setter, just assign the new value to the property rather than doing anything else. Now, there are a couple other keywords that we use when we're making properties out of objects. So the first thing we're going to do is change this char star property declaration to an NS string. And then we're going to move this pointer, and it really doesn't matter, but just because it's kind of syntactically correct in Objective-C, we're going to move it to the name of the object. So we have an NS string property called name. The problem here is that when name gets reassigned, what does it do with the old object? NS string and a lot of these NS objects are what we call immutable. They cannot be changed. So what will happen is if we just assign a new NS string to name, it doesn't know what to do with the old version because these are immutable. So we need to tell it what to do. And in order to do that, we need to peek a little bit into the subject of reference counting. When an object is made a property out of, and when it is assigned for the first time, it is born with a reference count. A reference count is just a counter, and it counts from 0 on up 1, 2, 3, and so forth. When that reference count reaches 0 again, that object will be deleted. And this is how reference counting works. Rather than having garbage collection that goes out and looks for any objects that are nil, Objective-C has reference counting. Now, prior to iOS version 5, we had to manage this reference count by ourselves. And we had keywords, we had messages that were sent to any subclass of NS object that were things like release, auto release, and things like that enabled us to manage the reference count on objects. Now, we are using automatic reference counting now. Automatic reference counting does a real good job of doing this for you. The bottom line here is that if this object if you want this object to start with a reference count of 1, then instead of using assign, you use the word strong. Now, this NS string, at this point, will be born, so to speak, with a reference count of 1. Why does that matter? Well, if it's born with a reference count of 0, the next time through the loop, so to speak, automatic reference counting will deallocate the memory, free the memory for that object. So if our application at the application level needs to know about this object and needs to retain this object, then we use the keyword strong. And in this case, we do need that. Now, if this object were going to be made, if this object were going to be added to, let's say, an NS array of strings later, at some point, then we could use the keyword week. In that case, name, the NS string, would be born with a reference count of 0. So week means 0, strong means 1. And then when we added it to the array, let's say, or whatever collection we were going to add it to, at that point, because another object has a reference to the name, it would have a reference count of 1. If we had made that strong, it would be born with a reference count of 1. When we add it to the array, it would have a reference count of 2. Later, when the array gets deleted, the object name would have a reference count of 1 and might never get deleted. So, if it's going to be immediately added to another object, we would make it weak. If it's not going to be, as is the case here, we make it strong. This is almost an oversimplification, but really that's about as difficult as strong and weak really get. So really, when do we use weak? When we get into using view controllers and we're dealing with programming iOS applications with iPhones and iPads, and we have views and things like that, typically, and this is a preview, typically we use strong if the object is either like an NS string or an NS array or something like that we are going to use within our application and want to retain. But we use weak for any subview of the main view that will be immediately attached to the main view. Now, I'll go over that again, and we're going to talk about that when we get to the subject of view controllers and their views and those views' subviews. And we'll talk about what should be strong and what should be weak at that point again. So don't worry. But this is kind of a preview into how that works. Now, because we have made this an NS string, then we need to make this parameter an NS string, right? Because we want to init with an NS string. We could actually init with a car star, but... And then this is the kind of syntax that we use. An NS string pointer called part name. Okay. And then here, we need to change this as well. Notice that synthesis still works. Name still works just fine. Name now is an NS string. And when we assign, since part name is an NS string, the assignment is just fine. And what this will do is, since NS string is immutable, and since it has been declared to be strong, what happens under the hood is in the setter, the old version of name, of self.name, will be released. Then the new version will be assigned into self.name, and then it'll have a reference count of 1 again. So the old version gets released, it has a reference count of 0. The assignment happens, it has a reference count of 1. And this all happens behind the scenes. Very rarely with automatic reference counting do we have to get in and fiddle with the reference counts and make sure that everything happened. In fact, those keywords that manage that, like auto-release and that kind of thing, those keywords are gone. So if you use ARC, if you use automatic reference counting, it's 98.5% of the time, let's say, you never have to worry about memory management. But there are some cases where you do, and it always pays to know what's going on here. So now, this method, our init method, will work just fine. So now in main, when we want to call that method, let's say we're going to have part myWidget. Let's call it myWidget. Up, and it's still a pointer. And now, how do we do this? Well, the first part's easy enough. Part alloc, right? And then, whoops, wrong way. And then init with, and let's see, what did we call that? Unit with name. We'll just grab that. Unit with name and number. Part alloc. Actually, there's even a better way. Watch this. If we import part, which we should remember to do, we'll get it as a tooltip. Now, because this is an NS string, we need to use the string or the objectify deal. And let's call it widget again. And then the number. Why mess with perfection, I guess, 36. Okay. Now, there's another thing that is kind of a neat tool. If you have a lot of parameters and your method name is split up over a lot of parameters, if you hit enter, it will align the colons for you. And so this can be nice when you have a nice long method name with many parameters. So now that will work, and then all we have to do is get out the information. So let's just say printf, or even nslog, but printf doesn't give us all that other information. And then string digit my widget dot name, my widget dot number. Okay, this won't work, and it's telling us it's not going to work. This is a bad format specifier for an NS string. Remember, my widget dot name now is an NS string, not a this. So it's telling us the format specifies type char star, but the argument has type NS string. That's just what I said, only it says it better than I did. So the way to get this is either to use the UTF-8 string, which I think we'll just go ahead since we're doing a printf here. Remember, from an NS string, if we want a char star, we can get that by using UTF-8 string, like that. And that'll give us that. That'll give us this as a %s. And there we go. That works. Or the other way to do this is to use nslog, which will give us a lot of extra information that we may or may not want. We'll put a new line here. And then here we would say nslog wants an NS string. It also takes format specifiers, but we begin with an NS string, and then we use %at. And this says, give me the description of the object that I'm about to pass. And then D, and then a new line. And that we can use my widget. My widget dot name directly, because my widget dot name is an NS string, and then my widget dot number. All right, get rid of that one. So this will print out the same information twice, essentially. Remember, with nslog, though, you're going to get the extra information of the log time, the address in the strong week, and so forth. So widget 36, widget 36. The difference is that here we are nslogging with an NS string that is a format string. Here we are printfing with a char star string that's our format string. And the %s format specifier doesn't work for an NS string. We would need to use nslog with the %at format specifier. Thank you.